Hey folks, today we're not just going to show how easy it is to deploy an application with Google Cloud Run, but really focus on how easy it is to deploy a maintainable application with Google Cloud Run. Things that should be table stakes, like automatic deployment and source code management, will be built in. And what do I mean by maintainable? I really mean that if you walked away from this application for a year, you should be able to come back and make changes or modifications without figuring out how to reset up your environment, figure out how this application was deployed, how it's all glued together, but really be able to open it up, make changes, and update your code as you need to. And the great thing about what we're going to do today is while we're going to use the Cloud Console and we're going to use a lot of automation built into Google Cloud to deploy this, everything we're going to do, from the continuous deployment to the container build to source code management, we can all break glass on these features and add more advanced functionality if we had requirements that made us do so. But things like the gcloud command, YAML, containers, all that good stuff is super powerful, but it can also be a little bit intimidating at first. But again, we're going to do it so it's nice and simple, but also not locking you into a Fisher-Price first application that if you ever did need to make changes, you have to go in and break that application and basically redo everything from scratch. And really my hope is that if you see how easy this is to do and how easy it is to maintain, that you're more comfortable going out there and creating new applications, creating glue code, and really bringing more value to your environment. For demonstration purposes, I've created the classic matching cards game, which has a deck of cards face down, and you have to match the pairs until you're done. There's really nothing special about this application. It's a basic Node.js Express app, so we'll do a simple npm install, then npm start to get it running on our local machine. The application itself serves static HTML and JavaScript files out of the public directory, and is combined with a simple API to return the card deck information. The card deck itself uses a flat JSON file as the database for simplicity versus setting up a database like Firestore or MySQL. The source code is available here, as well as linked in the video description below. From the code, you'll notice that there was no Docker file. That's because we're going to use the Buildpack function in Cloud Run to let it handle that. These are CNCF compatible build packs that build source code into container images for us. Not to spend too much time on this, you can learn more about Buildpacks on buildpacks.io. Now, if more control was needed, or it was desired to use a language that isn't supported yet, then a direct Dockerfile can be used. But back to maintainability, we'll follow the principle that the best code is no code at all, and I think that applies to Dockerfiles too. Now, to store our code, you can use third-party products like GitHub or Bitbucket, or we can use Cloud Source Repositories, which is built into Google Cloud. We'll be using Cloud Source Repositories here. Let's create our repo and push our code. You may be thinking, oh boy, now we're creating Git repositories and the whole simple promise is going to crash and burn. But we're only going to need a few commands that will be provided by the console. You could contrast this to Cloud Functions that has a very basic editor built in as a tab of the service. But with this, we keep the code in a location that provides better maintainability through the power of Git. And honestly, editing inside the service tab is not particularly great. Now that we've created the repo, we'll choose the option to push our local repository, as we already have code on our local machine. We're going to select the option to use the Google Cloud SDK as our authentication method. And we're going to make the assumption that you've already set up the Google Cloud SDK and initialized it to your project. So we're only going to copy the command that sets that up as our credential helper. Then it's really just setting up and pushing with Git. First, we're going to go to our local code and we're going to initialize it as a local Git repository, add our code, and commit it as the initial commit. We're going to go back and we're going to take the code to add the CSR repo as our remote repository and paste that in. Then we're going to take the code to push our code up to CSR and push that in. Now our code is on Google Cloud Source Repositories and we can refresh the page and our code is visible. Now we're going to create our Cloud Run service. So we're going to go under Compute and select Cloud Run. And at the very top, we'll go ahead and click Create Service. We're presented with the option of lots of different regions, but I'm going to select South Carolina, US East 1, since that's closest to me. I'm going to give the service the name match game, and I'm going to allow unauthenticated invocations. Now I have the option of either deploying a single revision, but I want to do automated deployment, so I'm going to select continuously deploy new revisions from a source repository. We've already got the source repository set up, so we're just going to enable the Cloud Build API and enable the Container Analysis API just for good measure. And as mentioned, we could have used GitHub or Bitbucket, but we used Cloud Source Repository, so we're going to select that here as our repository provider. And our repository will show up in our dropdown and select that. Now, as mentioned, we're not using a Dockerfile, even though we could. We're going to use our Google Cloud Buildpacks, so we're going to select that here. And I have the option of modifying this if I didn't follow the normal entry point behavior, which is just doing an npm start, but I did, so I'll select save. That trigger will be created when I create the service, but you can see our source repository here and what's going to happen. I'll click create. My service is now going to be created. And you can see we're setting IAM policy, we're creating a placeholder revision, we're routing the initial traffic, and then we're creating that Cloud Build trigger. And that Cloud Build trigger itself is going to do the building and deploying from repository. If we click on the logs link, it will take us to the history view of the current Cloud Build job. We can see the 3 steps that were automatically created for us. First, the build pack is going to create the container, then that container is going to be pushed to the Google Cloud Container Registry, followed by that, the container being deployed to a new revision of the service. We don't have to check out Cloud Build at all, and really this is totally transparent if we let it be, but it's nice being able to break glass if desired. That's one thing you'll see with this process, is that it's automated but flexible. Once the build completes, the new revision is visible, and under the revision details is a direct link to the source code, and more explicitly, a direct link to the exact commit that the revision was built from. Clicking the URL provided, the application is now publicly available and anyone can play the game. To recap, up to this point, we've achieved the following. Our source code is stored in Cloud Source Repositories and is safely tracked and available. Every time we commit to our master branch of our source code, a container will be created. That container will automatically be stored in Google Cloud Container Registry, and that container is sent to Cloud Run, which sets up an HTTP endpoint that runs our application every time it hits hit, plus all the infrastructure necessary to do that. But let's fast forward to the future. When we've forgotten everything about what we did to set this up, I want to demonstrate how easy it is to get your bearings, find your code, make changes, test those changes, deploy new versions, and even allow testing between them. So now, months later, we remember our application was deployed to Cloud Run, but that's about it. We navigate to the Cloud Run service page, and we find our match game service. Inside our service, we first check out the basic metrics exposed to us, like recent request count, latency, and billable container instance time. At the top is the build history, which shows us the date the last build was done and gives us a link to the build result. Now, inside the build result, there's a link to the source that was used to build the service and the specific commit that was used. So now we know how the service was behaving, how it was deployed, and we have direct access to the source code. We also could have found information inside the revisions tab, which shows us the container image that was serving the app, and we can pull that container down and play with it locally if desired. And we also get another link back to the source code on Cloud Source Repositories. To actually edit our code, we're going to use the Eclipse the IDE, which is built into Cloud Shell. We also could use the clone option to download our code onto our local machine. And we could edit it with Vim or whatever local text editor we would like to use. After doing this, we could do a commit and a push back to the Cloud Source Repositories, which would rebuild and push our code. But for simplicity's sake, we're going to use the Eclipse the IDE, which is built into Cloud Shell, by just clicking the Edit Code button, which will first let us know that we're going to clone this repository into Cloud Shell and confirm we trust it. Now the editor is going to open inside that repository. And one thing I like to do is just open that folder as the workspace to make using the get extensions built into the editor a little bit more simple to use. Now we can open our source code, but what we're going to do is we're going to open the HTML site page and rename it from match game to concentration game, which is just another name used for this type of game. Now we can click our get extension on the left side. We can see what we changed, and we can go ahead and stage that file by clicking the plus sign. We can enter a commit message and we can make that commit. Next up, we'll click the triple dot drop down and do a push to push that code back into Cloud Source Repositories. Now if we refresh the service page, we'll see that we're building and deploying from the repository. We can open the logs, go to Cloud Build itself. We can see our 3 steps from the build pack to the push to the deploy are going to occur. If we click the commit itself, it'll open Cloud Source Repositories for us, and we can see what was changed. We can expand the index.html file, and you can see that just the name of the title was changed. Now that everything's done and that revision is pushed out, we can see that the latest build was successful. We can click the URL, and now the new name is visible within the website. If we go back into our Cloud Shell editor, let's make another change. We'll just remove the exclamation point from our console log command when we start the service. We could do an npm start at the bottom, or we can go on the left side. The npm scripts are clickable for us, so we can just start it. It is going to fail because we haven't done npm install yet, so we'll just go to the terminal, run task, and do an npm install, and that'll pull our node dependencies down for us. Now that those are installed, we'll just click start one more time. If we go up to the web preview option, we can actually test this before even deploying it to Cloud Run. So we did a simple web preview, and now our application is running on our own Cloud Shell. And we can test it out and make sure that it still works. Once we've confirmed that it's working, we can go in and do our git commands, stage our file, give it a commit message, perform the commit, and then do the git push one more time back to Cloud Source Repositories, which will again kick off our cloud build trigger. Quick refresh of the page shows us that the build is happening once again. We can even go into our trigger section of Cloud Build just to see what was actually created for us, and we can edit this trigger to kind of see all the stuff underneath it. Again, this goes back to the ability to break glass if we needed to. Now that our new revision is deployed, all traffic automatically goes to it by default. We could manage traffic and have it do a split kind of canary deployment, or if we wanted to, we could actually give one of our old revisions a custom name. So we'll just do that. We'll give it the name original and save that, and Cloud Run will make that revision available with that custom URL. So now we have 2 revisions active. We can click the original link, which has that custom URL, and it will take us to our old version of the site. We can click our latest version and it'll bring us to the latest. Now you see run match game and concentration game, the 2 different versions that we had deployed. To wrap this up, we've deployed our application and sprinkled in all the goodness of Cloud Run. At the end of the day, we have our source code in a secure, durable location, and we can edit in a variety of ways. We can use Vim or VS Code, or we can use the built-in Thea editor within Cloud Shell. And the great thing is, we ignored all the dirty work of containers, yet we still have an application that leverages them fully under the hood. And if we needed to break glass on any of these components to get more advanced, we could without having to recreate things. If we wanted more customization of our build process, we could go in and create our own Dockerfile instead of using Buildpacks. If we wanted to add more steps or modify the steps of our CI/CD pipeline, we can go in and modify our Cloud Build YAML file. And if we wanted to go all the way and we needed even more flexibility than Cloud Run provides, we could use things like Cloud Run for Anthos to run it directly in GKE and get all the goodness of the Kubernetes environment around it. Or we could take our application, use the container we built, and deploy it directly into Kubernetes and GKE or any other Kubernetes platform itself. With this level of openness combined with the great developer experience baked on top, we can easily deploy maintainable applications. I encourage you to give this a shot, either with your own application or using the matching game sample we used today. The source code as well as links to references within the video are all in the video description below.